Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Late 2023, Mistral drops a model called Mixtral, and reviewers are genuinely confused. The model card says 47 billion parameters, but the inference logs show only about 13 billion doing the work. So, which number is the real one?
And I'm guessing the annoying answer is both.
Both, and untangling that forces you to rethink what model size even means. Mixtral was trading blows with Llama to 70B, a model 5 times its apparent size, while costing about what a 13B costs to run. The trick is mixture of experts.
So before the trick, what's the wall it's getting around?
The wall every dense model hits. In a normal transformer, every token goes through the same block of weights on every pass. If a layer has n parameters, every token pays the full cost of all n. No exceptions. So you're trapped. You want more parameters for more knowledge. But each one you add costs you compute at inference, forever.
And the question Mo asks is, can I add the parameters without adding the compute?
Exactly that. So it replaces that one big feed-forward block with two things, a set of experts. Mixtral has 8 separate feed-forward networks and a tiny router. The router is a small learned layer that looks at each token and scores all 8 experts. It picks the top 2, and the token only flows through those 2. The other 6 get 0 compute for that token.
Hold on, let me make sure I've got the picture. It's not splitting one expert across the token. For this specific token, 2 experts light up, 6 go completely dark. And for the next token, it might be a different 2?
Perfect. Think of a hospital with 8 specialists. A patient walks in, and a sharp triage nurse, the router, sends them to the 2 specialists who actually fit the case. The other 6 aren't consulted at all. Next patient, a different pair. Everyone's on payroll. But you only pay for the 2 you use each time.
So that's where the savings come from. 2 of 8 active, you're skipping 75% of that feed-forward work.
6 of 8 skipped. So 3/4 of the feed-forward compute just never happens. Now the parameter arithmetic. 8 experts at roughly 7 billion each, plus about 7 billion shared. Attention, embeddings, and you land near 47 billion total. But only 2 experts fire. So active is 2 times 7 plus the shared 7.
That's 21 billion though, not 13. Where did the gap go?
Sharp catch. And it's the part everyone trips on. That 13B active number isn't a raw parameter count. It's measured against compute, against flops. The feed-forward part you're sparsifying is the bulk of a layer, and you've cut it by 3/4. Fold in the shared layers, which are leaner here than in a true dense 13B, and the effective compute budget lands near a 13B model. The headline number is a compute claim wearing a parameter costume.
Let me push on something because this sounds suspiciously like a model parallelism. Splitting a model across GPUs.
It really isn't, and that's a common mix-up. Model parallelism splits one set of weights across devices just to make it fit in memory. Every weight still runs for every token. Mo is the opposite axis. All the weights are present, but each token only computes through a slice of them. Parallelism solves memory. Mo solves the compute versus capacity trade-off. You can even stack both.
And the router. Does someone hand a scene? You do code, you do numbers.
No, and that's the elegant part. The router trains end-to-end with everything else. Through gradient descent, it discovers which expert handles which tokens. One drifts toward code, another toward names or numbers. The specialization is emergent. Nobody designed it. The model found whatever routing minimized its loss.
This is sounding too good. Where's the bill?
3 real costs. First, memory. And this is the big one. Even though only 2 experts fire, all 8 must sit in GPU memory. Mixtral needs about 87 gigabytes at FP16, which won't fit on a single 80 gig or 100. A dense 13B fits easily. So you're forced to spread it across 2 or more GPUs.
So runs like a 13B is true for compute and a flat-out lie for memory.
That's the exact trap to remember. If a vendor announces 600 billion total, 30 billion active, and says runs like a 30B in every way, no. You still need enough GPU memory to hold all 600 billion resident. The compute is 30B. The hardware footprint is not.
And the other two costs?
Load balance collapse. If the router falls in love with one or two experts, they get overtrained, and the rest go to waste. You fight it with an auxiliary load balance loss that penalizes lopsided usage, and tuning that is fiddly, and training instability. Routing is a discrete, noisy decision, so the gradients through the router are jumpy. More models are genuinely harder to train than equivalent dense ones.
And yet, the frontier labs all went this way.
All of them. DeepSeek pushes it further. 256 experts top it. Llama 4 ships more. 17 billion active out of as much as 400 billion total. GPT-4 is widely believed to be more from its cost and latency profile. The bet is consistent. Frontier quality at subfrontier inference cost.
So the one line to walk away with?
Mixture of experts decouples knowledge from compute. You pay to store all the parameters, but you only pay to run a fraction of them per token. Just never confuse the active count with the memory bill.
Big brain, small bill, but you still buy the whole brain. That's the Datarekha audio guide. See you in the next one.